connection via Zoom. So we'll see if it works. We've got quite a program to go today. Here are some of our goals. Talk about the size and scale of the solar system, about our place in space, about space in general. And I really want to get our arms around some really big concepts. If you just take the Earth-Sun system, you introduce some basic concepts about day and night, the seasons and the year. You throw the moon in there, you've got another great number of concepts to introduce. And just like the real estate agent, we'll talk about location, location, location. Our location in the solar system, in the Milky Way galaxy, our place in the universe, or as some might suspect, in the universes. If we have time toward the end, as well as questions, there are some current events I'd like to introduce, talk about meteor showers that might be visible from New Jersey for the remainder of this year, what's up in each direction in tonight's sky and the sky that we'll have the next few weeks, a comet that will be visiting us in May, some NASA missions, some visiting planets later in the year, and maybe you're thinking about getting a telescope. I have some recommendations, as well as the links that Kate made reference to. I know it's an ambitious schedule, and by the way, I'm not going to do it in any given order, so it may get a little crazy. Bear with me. I am not an astronomer nor an astronaut, but you can download an app from NASA, take a selfie of yourself, and put yourself right inside a spacesuit too. So while you're home and everybody's locked in, get on the NASA website. There's plenty to do there. Kate mentioned that I'm frequently up in Maine where we do night sky viewing, but I also do solar astronomy, sometimes right here on the shore of Eagle Lake, where I'll grab any passing family and make certain, if they've never seen the sun, to be able to see it safely in my solar telescope. Lots of friends up there, fox, porcupines. The same deer comes to the field I go to each night. I've even had a great encounter with moose up there in Maine. So I encourage you to get up there for the night sky, if nothing more. That sky is made possible by the fact that there's so little light pollution up in Maine. And you can see stars like we just can't see anymore here in New Jersey. And that brings me to a message, because we're here because of Duke Farms. They're our host, and their focus on ecology, on the environment, on all the natural resources, wind and air and water, and protecting the animals, the insects, the fish. But there is another resource, and that resource is darkness and dark skies that we've been losing all too quickly, and we've been contributing to it with poor lighting choices. Now, this is a view of the Milky Way that few people will see. It's from Sand Beach and the lifeguard station at Sand Beach at Acadia National Park. Your eyes couldn't actually see this many stars at night. A camera can capture more light than our eyes can. But it does underscore that where there is no light pollution or less light pollution, the skies open up and you can see many of the lighter stars. So darkness is also a resource worth preserving. I've included a link in the links that you'll get via email that includes some information from the International Dark Sky Association that really focuses on preserving the darkness and underscores how poorly we've been taking care of our skies. This image from space just shows you how much light pollution there is from every city on the eastern seaboard. Zooming into New Jersey, we're sandwiched between New York and Philadelphia. So in addition to our own light, we get the light of our neighbors. And the light near Duke Farms is really pretty bad. Up by me in Schooley's Mountain, it's not so terrible, but I share the same sky that is glowing from the light pollution that we all can do something about. And that is making a conscious choice when we choose lighting either at our homes or in our communities. And just as Duke Farms has consciously done, they've gone with fully shielded lights that protect the light trespass from hitting us and causing glare or bleeding into our windows and reflecting up into the night sky. So there are things you can do something about to contribute to reducing light pollution and making the skies more enjoyable for everything. I encourage you to visit the International Dark Sky Association website, whose link you've got, and to do some things around your house in terms of choosing lights that are more favorable. We all have gone to the LED lights, but instead of going with the blue light color, you can go with the more yellow lights that are kinder on our eyes, and go with shielded lights that direct the light downward to where we want rather than everywhere else. I look at this beautiful picture of the world from space and think about the fact that it is turning all the time. And it made me think, as I put this program together, of sitting at home with my mom in the 50s watching as the world turns. The world is turning. It spins sort of like a top. Here's a view of the world with the North Pole up, the South Pole down. The world doesn't spin like a top straight up and down, at least our world doesn't. Some worlds do. The moon spins basically straight up and down like a top. The sun does, Jupiter does, but the Earth was hit by an object as the solar system was forming billions of years ago. Many of the planets were jostled by impactors that knocked them over into various positions. And ours is tilted, and Mars is tilted at about the same tilt, but it is spinning. And from this view with the North Pole up, it is spinning in a counterclockwise direction. And that spinning, that turning toward the sun and turning away from the sun, is what creates day and night for us. So that's the first concept I want to introduce today. Here is a view from the International Space Station, only about 250 miles above the Earth. And you see the Earth here below with the separation between day and night. The terminator is the line that separates day from night. And as the Earth is spinning in a counterclockwise direction, these people are leaving darkness and coming into dawn as the Earth spins. The sun seems to go across our sky left to right, but that's only because the Earth is spinning in a counterclockwise direction toward it. The folks on this side of the Earth are spinning into darkness, into night. The same holds true on all worlds. Here's a picture of the terminator on the surface of the moon, taken by a friend of mine who lives in Hillsborough. And here again is the terminator separating day from night. So that's the first concept. Now, every object in space is being shined on by its star. Every object in our solar system is being shined on and illuminated by the sun. And every object in our solar system is always half lit. Here's an illustration we're going to revisit later when we talk about the phases of the moon. But I wanted to show you this image because it illustrates the moon in its different positions throughout the month as it circles the Earth. The sun is in this direction, indicated by the yellow arrows to the right. So the right side of the moon is lit all the time. We don't see it that way from Earth, but that's just because of our position, the sun's position, and the moon's position. We'll get into that in a couple of minutes, but I wanted to illustrate that the Earth is always half lit, the moon is always half lit, comets, meteors, dwarf planets, they're all always half lit by the sun. There's one exception, and that's during eclipses, but we're not going to talk about the exception right now. So here we are at Duke Farms, and here's a map showing us at Duke Farms. And Duke Farms is in the town of Hillsborough. That's how we describe its location. But we can also describe its location using its coordinates, its latitude and its longitude. And those are used by using degrees. So Duke Farms is located on the Earth 40 degrees north and 74.5 degrees west. Well, what does that mean? There are no real lines on the Earth, but on a map or on a globe, they often put lines to help describe different positions on Earth. There is a position along the equator, along the middle of the waist of the Earth, that is 0 degrees, and that is the equator, or the zero latitude, 0 degrees. There's a line that goes up and down, and here's one that goes through a tiny little town in England called Greenwich, and that's where the 0 degrees longitude is. So on Earth, if you're on the equator, like in the country of Ecuador, you're at 0 degrees latitude. Central America here, the line is 15 degrees north of the equator. Florida is at 30 degrees. Maine is about at 45 degrees. Alaska and the Hudson Bay are at 60 degrees. Greenland, the Baffin Bay, is at 75 degrees, and Santa Claus and the elves are right here at the North Pole at 90 degrees. There's also latitudes below the equator, south of the equator, and longitude lines from England going 15, 30, 45, 60, 75 degrees goes right about through New Jersey. So that is our place at Duke Farms, 40 degrees above the equator, 74 degrees west of Greenwich, England. Now, Hillsborough is not far from where I grew up in Springfield. In Springfield, in my backyard, when I was a child, I used to dig holes in the ground so deep that my mother used to say, if you keep digging, you'll end up in China. And I used to think that if I dug a hole deep enough, I'd go right through the center of the earth and end up in China. Well, that's not actually true. Duke Farms is not that far away from Springfield. And if you dug a hole at Duke Farms and went right through the center of the earth, all the way to the other side of the earth, you would end up in the middle of the Indian Ocean, a couple thousand miles from Perth, Australia, a couple thousand miles from Antarctica, a couple thousand miles from South Africa and Madagascar, the middle of the Indian Ocean. I call that place anti-Hillsborough because it's exactly the opposite of Hillsborough. So when it's daytime in Hillsborough, it's nighttime in anti-Hillsborough, 40 degrees south of the equator and 74.5 degrees east of Greenwich, not west of Greenwich. It's the exact opposite point on Earth to where we are at Duke Farms. So we now have the concept of day and night. As I said earlier, the Earth doesn't spin exactly straight up and down like a top. It's tilted a bit. And in addition to spinning around on itself to give us day and night, while it's spinning, it's also traveling in a circle, a huge circle that goes around the sun. It stays about 93 million miles away. That's a long way, but it goes around the sun, and the time it takes to go around the sun is 1 year. So it takes one 24-hour period for the Earth to spin once. That's a day on Earth. And it takes about 365 days to go around its star. That's described as a year. But because of its tilt, we get heated up differently depending on where we are in our pathway around the sun. They have a special name for that pathway. It's called an orbit. So they say that the Earth revolves around the sun in an orbit that takes a year. We're somewhere right about here right now, sort of between the first day of spring, and we haven't reached the first day of summer. But let's take a look at Earth in summertime. In America here, we're in the upper portion of the Earth. We're tilted toward the sun. Whether it's day or night, we're still tilted toward the sun in the summer. And because we're tilted toward the sun's rays hit us very directly. And because we're tilted toward the sun is higher in the sky during the summer. The people who are in the southern hemisphere, who live in Australia, South Africa, South America, they're getting more glancing rays of the sun on a steeper angle, so they don't get heated up as much during the day. Their sun is coming in at an angle, so it doesn't heat up quite as much as it does in the summertime for us. So summer, you have rays that hit more directly. In the winter, you have rays of the sun that hit on more of an angle. And because the sun is higher in the sky, it spends more time in the sky during the day and allows the land and the water and the buildings and you and I to heat up more during the day. And that's why it's hotter during the summer, more hours of sunlight and heat. In the spring and fall, there's an average amount of sunlight, equal length of daytime and nighttime, so sort of in between temperatures. In the wintertime, the sun is so low in the sky that it spends less time in the sky and heats up things for fewer hours, and that's why things stay cold in the wintertime. At Duke, things are beautiful here in the summer, things are in bloom, the leaves on the trees are there, but things are equally beautiful in the winter. It's just that in Hillsborough, when we're having summer, anti-Hillsborough is having winter. And while they're having winter, we're having summer. It's just the opposite. I know it's going to be really strange to think of this, but people down in Australia have Christmas time in the middle of their summer. They wear bathing suits, they go on boat rides, not sleigh rides, and of course Santa pulls the sled with kangaroos, not reindeer. So we've actually learned quite a few things that I just want to review with you to make sure that everybody's on the same page. And I call these universal concepts. So planets, moons, and other things in space spin. And another word for that spin is rotate or rotation. And as they rotate, they face toward their star or away from their star into the darkness of space. And that's how we get day and night, because those bodies are facing the sun or their star or facing away. Another way they move, in addition to spinning, is they move in space around their star in a path called an orbit. So things that go around stars are called planets, and it takes them a year to go around that star. Things that go around planets are called moons or natural satellites. And the amount of time it takes them to go around is called a month. We've shortened that by dropping an O and calling it a month, but the word month comes from the word moon. Now, on Earth, it takes about 365 days to go around that sun, our star. But not every planet takes that long. Some planets go around their stars quicker than 365 Earth days. Some planets take much longer to go around their stars. We see this picture of the solar system very frequently. And if you look at my shirt, I've got planets that are pretty much equally spaced away from the sun. Well, that is totally wrong. This is a terrible picture of the solar system. First of all, planets are not equally spaced away from the sun. That's not how our solar system works. And these planets are basically the same size. They're not very different in size. I like this picture of the solar system better. Now, granted, the size of the planets is not accurate. In fact, the planets are the same size as the sun in this model. That's not right. We know that's not right. But the reason I like this illustration is it gives you a good idea about the size of the solar system, because they have this little inset expanded down here. Very close to the sun are the four rocky planets: Mercury, Venus, Earth, and Mars. And they're all crammed in this tiny little circle up here, very close to the sun. This diagram didn't see that very clearly. This diagram is far more accurate and shows you all the great space that occurs farther out in the solar system, where Jupiter and Saturn, Uranus, and Neptune orbit. Now, you're going to hear me make reference to Pluto. I know scientists have made it a dwarf planet, but I refuse to accept that, and I'm of the group that believe that Pluto is still a planet, and in all of my exercises and descriptions, I keep including it. I have not made it sit at the little people's table at Thanksgiving. All right, here's something very surprising. We know that Pluto is the farthest planet from the sun, but for 20 years, from the years 1979 to 1999, because Pluto has such a strange orbit, it actually got closer to the sun for those 20 years than Neptune. And it was Neptune that was farthest for the sun for just those 20 years. Pluto takes such a long time. It takes 249 years to make one orbit of the sun. So it was discovered in 1930 and hasn't even celebrated one birthday since then. As I said, the pictures of the solar system you've seen have all been inaccurate your whole life. One activity that I sent you a link to looks at the size of the planets instead of their orbits. And by using Play-Doh, you can divide Play-Doh into very accurate piles of clay to fully represent the accurate size of the planets compared to one another. And when you do this activity, and I must warn you, parents, you have to start with a minimum of 3 pounds of Play-Doh. If you start with any less, you will not be able to complete this exercise, because it illustrates just how large Saturn and Jupiter and Saturn are to the other planets. But even Uranus and Neptune are tiny in comparison. But worse still, or smaller still, are the Earth, Venus, Mars, and Pluto is not even visible in this scale. And that's why you have to start with 3 or 4 pounds of clay. I'm going to introduce a scientific concept to you now called the astronomical unit. And it's nothing more than an abbreviation. The distance from the Earth to the sun varies a little bit during the year. It doesn't stay the same distance from the sun, but it's pretty close to 93 million miles. Well, in describing the size of the solar system, astronomers would have far too many zeros to account for, so they've abbreviated it with a new concept called the astronomical unit. And it's simply 1 AU is the distance from the Earth to the sun. Another way of getting an idea of how big the solar system is and how distant the orbits of the planets are is called the solar system in your pocket. I'm not going to describe it now, but by folding a piece of adding machine tape that has the sun at one end and Pluto at the other, you will see exactly where all the planets fall. You will be surprised to learn that the planet that's located midway between the sun and Pluto is the planet Uranus. And only one other planet fits in between those two. Go to that link when you receive it, and you can do this fun activity at home just with a piece of paper. It will show you the distances. Now, in addition to a year not being 365 degrees everywhere, a month is not 29 days everywhere. The moons of Jupiter, some of them make it around Jupiter in almost 2 days or 4 days, much faster, even though Jupiter is so large. And a day is not only not 24 hours everywhere, but there are places where a day is longer than a year. I know that sounds kind of funny, but they believe that it was caused when Venus was struck early on 3-4 billion years ago. It was struck so hard that it flipped Venus upside down. Venus doesn't spin in the same direction it goes around the sun. It's the only planet that spins opposite that. It got hit and knocked upside down and spins in the opposite direction to all the other planets. In addition to that, it takes Venus 240 Earth days to spin once. That's how long its day is, 240 Earth days. Very slow spinner. It goes around the sun in only 225 days. So a year on Venus actually takes less time than a day on Venus. Pretty strange. Another difference between the southern hemisphere and anti-Hillsborough and Hillsborough is we see various stars and patterns of stars called constellations when we look in the night sky. We see the Hunter, Orion. We see the Bull, Taurus. Well, some folks in the southern hemisphere see those constellations too, but they see them upside down from the way we see them. Canis the dog is upside down. And there are some additional constellations way deep in the lower portion of the southern hemisphere that we never see, with strange constellation names like Peacock and Compass and Level and Flying Fish. We don't see any of those constellations no matter what time of year it is. So depending on where you live on Earth, your sky can be very different at different times of the year, and also different depending on which part of space you're looking out into. When we look at the moon, we see this pattern on a full moon. I always look for the Mare Crisium, the Sea of Crisis. It's one of the smaller, more distinct circles, and it's on the right side of the moon as we see it from the northern hemisphere. The kids who grow up in Australia see the Mare Crisium on the lower portion of the moon, because the moon is upside down from the view people have in the southern hemisphere. So there are all sorts of differences between Hillsborough and anti-Hillsborough on the other side of the Earth. Day and night, winter and summer, upside down constellations, and a moon that is upside down from the one that we see. Speaking of that, I told you we would be talking about the phases of the moon. And the phases of the moon are kind of odd, because you'll also recall that I described at the beginning of the presentation that the moon is always half lit. All right, this is going to be one of the more difficult parts of my presentation, but it requires that you listen carefully and try to put yourself in the position I'm trying to describe. So let's take a look at the moon at the various times during the 4 weeks, give or take, that it takes the moon to go from one phase around the Earth and back to that phase again. So let's start with a new moon. Let's picture ourselves here on the Earth looking toward a new moon. A new moon is a moon that rises with the sun in the east. And because of that, it's in the glare of the sun, and we cannot see the moon. The moon is being lit from the other side from the sun, so we are seeing the shadowed side of the moon on the first day of the lunar month. A few days later, the moon has moved into a position, moving in a counterclockwise position around the Earth, and the sun now is lighting up, again, half of the moon, but from our view on Earth, we can only begin to see the right side of the sun lit up. So we see just a little crescent of the moon that's lit up on the right side. 1 full week after the moon's monthly trip around the Earth, we can see the whole right side of the moon is lit and the left side is in shadow. So half of the half is lit up, and that's why we call it a first quarter, half of a half. About 10, 11 days into the month, we see almost all of the right side and a little bit of the left lit from our view on Earth. And 2 weeks after the moon has started moving around the Earth, we now see the moon fully lit from the sun over our shoulder. This is a moon that is lit on the side that faces us, but we have to consider that's because the sun is behind us. We must remember that the far side of the moon is still in shadow. Again, half of the moon is always lit, half always in shadow. This is how it looks 2.5 weeks. In 3 weeks, as the moon is 3/4 of the way around, now from our view on Earth, this becomes the left side of the moon from our view on Earth. And the 3rd quarter moon shows us a moon that is lit only on the left side with the right side dark. Finally, and this moon is usually visible in the middle of the night when we're walking down the hallway or on our bus on the way to school, when we used to go to school, with the left side of the moon only lit and the right side in shadow, so that the crescent is now on the left. And finally, we get back to where the moon is rising with the sun and totally in the glare of the sun, so we can not see the shadowed moon at all when it's new. And that's why, even though the moon is always half lit, we only see the part that we see based on where we are, where the sun is, and where the moon is on its monthly trip. Now you can explain the phases to others and your friends. We have names for the different phases: full moon when it's all lit, a crescent when it's like a toenail, a first or last quarter when it's half lit, and the word gibbous means protruding like my big belly. Parents, this is a great way to illustrate the phases of the moon. I would recommend, to avoid the sugar rush, that you use those Oreo minis that you can get at the store, so your children can eat away the icing to reveal all of the phases of the moon. And it's interesting as well that the phases come out only at given times of the month. So a new moon, we said, rises with the sun and goes across the sky all day long. That's why we never see it. It's in the glare of the sun the whole way. A first quarter moon is the perfect moon for observing because it rises at noon and it sets at midnight. It's there for most of the school day. It's there after school. It's there in early evening. It's there before bedtime. It's there late for parents to enjoy before midnight. It's there all observing day. A full moon, and think of your experiences, the full moon always rises, since it's opposite the setting sun, always during a setting sun. That's the only way you'll see a full moon rise, is during a setting sun. And a third quarter moon that's lit on its left side always rises at midnight and sets at noon. That's again the one that lights up the hallway for us in the middle of the night when we go to the bathroom, or it's on the school bus ride to school in the winter when it's early morning and the sun has not yet risen. As well, just like the southern hemisphere people see an upside down moon, they see phases that go backwards. So their first quarter moon is left side lit, not right side lit like us, because they're seeing the moon going around backwards. Crazy, huh? Included in the links that I've sent you is a lunar journal, a moon observation journal that you can print out. And grown-ups or children can look at the moon on nights that it is clear, put the date down, put what time you observe the moon. Sometimes the terminator will be straight down the middle of the moon. Sometimes the moon will seem to be tilted left or right. Observe the moon when you can and draw a picture. Now keep in mind, and parents, listen carefully to this, you're not drawing a picture of the moon, you're drawing a picture of the dark sky. The pencil you'll be using is dark. The moon is light. So you're actually filling in the sky around the moon. You're not drawing the moon itself. What's left is the image of the moon that you're not filling in. You'll figure it out. There are directions as well. You may want to take a picture of this because I did not include this in the links. So take out your cell phones and take a picture of this. This is a calendar I have hanging next to my shaving mirror. And it reminds me of the week of the month, each month for the remainder of the year, when the moon is at first quarter, where the right side is lit and it's out all day from noon to midnight. These are the best days for observing. If you have binoculars or a spotting scope or a telescope, these are the nights that you can get a great view of the moon no matter what time of day or night. I just want to remind you, if you look at the moon during the day, during the first quarter, it's not going to be in the direction of the sun, but you must guard against anyone aiming a telescope or any magnification toward the sun. It would do great harm to their eyes, so do not leave the telescope unattended with the very young. Now, I showed you in that picture of a new moon and a full moon. You would think that we would have an eclipse a couple times a month if the plane of the Earth-Moon system were on the same plane as the Earth-Sun system. But this illustration helps show you that the Earth and Moon are tilted at about 5 degrees to what the Earth and the Sun are at. That little bit of a tilt avoids us having an eclipse every month. We end up having two solar eclipses on Earth each year, and 2 to 3, maybe sometimes 4 lunar eclipses on Earth. And what is an eclipse? Well, a lunar eclipse happens when the Earth passes between the Sun and the Moon. It happens every month at full moon, but because of that 5-degree tilt, the sunlight still reaches the Moon. In fact, when the Earth is perfectly in front of the Sun is so large that its sunlight still lights up the Moon, but it lights it up almost a coppery red color. And there's a scientific explanation for that. Our sky has lots of particles in it, and the sunlight reflecting off those particles captures the blue color, and that's why our sky reflects blue back down to Earth. The other light passes through. So as the Sun is behind the Earth, shining its rays through our atmosphere toward the Moon during a lunar eclipse, the blue light is filtered out by our atmosphere, and only the red light passes through space to the Moon and illuminates the Moon with light that has had the blue wavelength removed from it. And that's why at full moons, or especially at lunar eclipses, the Moon looks reddish or coppery yellow. And here's a graphical representation of the Earth coming between exactly the Sun and the Moon, and the shadow cast on the Moon, but some of the rays of the Sun being able to make it around. In a solar eclipse, instead of the Moon coming between the Earth and Sun, instead of the Earth coming between the Sun and the Moon comes between the Sun and the Earth in a solar eclipse. And it's a beautiful thing. A most remarkable coincidence happens here on Earth. The Moon is 1/400th the diameter of the Sun, but it is exactly 400 times closer. And the combination of those two facts means that when the Moon is perfectly aligned and passes in front of the Sun, it blocks all of the Sun's rays. So in the minutes leading up, we have to put on our solar eclipse glasses because we're looking toward the Sun and we're seeing the Moon moving in position. And I did this actually it was 2017. I was in Maine and I knew that a solar eclipse was coming through New Jersey, but only 72% of the Sun was going to be covered. I had to be on this line of totality that reached from Oregon to South Carolina. And I called a library in Greenville, South Carolina, and told them I was doing a show at their library on August 21st. And I went down. Some guys from New Jersey Advanced Media came. They took great pictures. We saw some of the most beautiful imagery you can imagine, including the diamond ring effect here and solar prominences leaping into space. Birds stopped chirping. Dogs stopped barking. A young romantic got on bended knee and proposed to his sweetheart, who smacked him on the shoulder and said, "Can you wait 2 minutes and 9 seconds till totality's over with?" A marriage made in heaven. Here's what it looked like at each stage of that eclipse from South Carolina. It was absolutely exquisite. And for that 2 minutes and 14 seconds, we got to see the corona, the atmosphere of the Sun, this electromagnetic phenomenon that is only visible. This was my first solar eclipse. I know people who've been to 25 solar eclipses, have spent their life fortune to travel around the world to see this, and I understand the beauty and why they do go there. Mark your calendars. April 8th, 2024 will be the next solar eclipse that will allow us to see totality. In New Jersey, there will be 90% of the Sun covered, but that is not enough. Comparing 99% coverage of the Sun to totality is like comparing a lightning bug to lightning. You have to get on the line of totality, and it will go through Mexico, Austin, Cleveland, Niagara Falls, Montpelier, Vermont. It'll go through Western Maine. It will not go through Acadia. I spoke to the superintendent at Katahdin Woods and Water National Monument. He said, April 8th, we might have 2 feet of snow or 2 feet of mud, he said, but come on up if you want to see it from up here. So please make your plans now before motel rooms go for $400, somewhere along that line. The moon is mostly responsible for the tides as well. Here is a picture from Prospect Harbor I took of these 2 lobstermen boats. The lobstermen and women have to know about the tides when they go out in the morning to set their traps, to retrieve their traps. Everyone in Maine has to know about high tide and low tide. There are 2 high tides each day, 2 low tides each day. If you walk out to an island at low tide, you better know when high tide's coming or you will be stuck there for 6 hours until low tide comes back. So what is tide? What are tides? Tides are the gravitational pull on the water and the land from the moon and the sun being close to the earth. Now, we already described the fact that the moon was 1/400th the diameter of the sun, yet it contributes 2/3 of the tidal pull. You know where you're when you're on a blanket on the sand, and a couple hours later, you've got to move that blanket back or you're going to get wet. That is the moon and the sun coming into alignment, pulling more at the water, pulling it into what's called high tide. So the earth spins one whole time in 24 hours. It goes through low tide, high tide, low tide, high tide, every 24-hour period. At new moon or full moon, so these are 2 time periods, 2 weeks apart. The moon and sun are pulling basically along the same line, and high tides are very high. Low tides are very low. Compare that with what happens on the alternating weeks when the moon is off to the side of the earth and not pulling in the same direction. High tides aren't quite as high. Low tides don't go quite as low. But you see, it is the moon more than the sun that creates our tides, because it is how close it is rather than how large it is that makes more difference when it comes to gravity. Hurricane Sandy, I'm not sure if it was a new moon or a full moon, but it took place at astronomical high tide. And that's why the destruction was worse than if it had happened 1 week later or earlier. So, that is our beautiful world. But the planets only make up the inner 1/3 of our solar system. We don't think of it that way. We think that's the whole solar system. It's not. Now, these pictures aren't to scale, but there's a section that begins at Neptune's orbit called the Kuiper Belt, and another section beyond the Kuiper Belt called the Oort cloud. And this is more a look of what it may look like. None of these little dots are stars. They are all comets. They are all dirty ice balls or icy dirt balls. And that is what a comet is. The comets that are in the Kuiper Belt circle close to the sun maybe every 50, 70, 100 years. The comets that are way out here in the Oort cloud, 100,000 astronomical units from the sun, they may take 1,000 years or 2,000 years to make their orbit to the sun and then come back out. And as a comet gets closer to the sun, it gets energized by the sun. Like I said, it's a dirty ice ball. And that ice, both water ice and frozen carbon dioxide, gets activated. It gets activated and starts giving off things. It gives off dust and gas as it gets closer to the sun. The closer it gets, the more gas and dust it gives off. And it has this beautiful tail, a tail created by the gas and dust coming off and by the solar wind. It actually has 2 tails. And that tail always goes farther from the comet. Even as the comet is racing out into space away from the sun, the tail goes ahead of the comet. It's not caused by speed. The tail is caused by the solar wind, by the solar energy making particles fly off, not by the motion toward the sun like a steam locomotive.
Hey, Ranger Bob.
Yes?
We have about 10 minutes. You
Perfect.
asked me to remind you.
Thank you.
You're welcome.
So, as the Earth each year goes through its annual orbit, it may sweep by where the comet had gone 10 years ago, or 50 years ago, or 80 years ago. But it went 80 years before that, and 80 years before that. And every time it goes, it leaves dust and gas hanging in the sky. And every time we pass that gas and dust, the Earth goes through that gas and dust, and the little particles of dust ignite in our atmosphere. And a meteor shower is nothing more than us going through the remnants of the tail of a comet that's hanging there in space. There are many meteor showers each year. 3 of the better ones this year will take place in August, October, and 2 in October. The first 2 will take place when there's a 3rd quarter moon, which comes out at midnight, so you have to go out pretty early in the evening to see those meteors. This is the best night to see the Perseids or the Draconids, but it's happening on either side of that night as well. So if it's not perfectly clear or you've got something else to do, just go out on the alternating nights. This might be better in the pre-dawn hours, like from 3 to 5 in the morning. That's when there are usually more meteors in a meteor shower. They aren't really, they're little dust particles from a comet. You know that now. I use the concept of astronomical unit to talk about distances within the solar system. Outside of the solar system, they use the light year, which is about 6 trillion miles. 1 light year, the distance that light travels in 1 year is 6 trillion miles. Space is so large that we use the light year to abbreviate distances. The closest neighbor to us in terms of galaxies is the Andromeda galaxy, which you can see with the naked eye. It's 2.5 million light years away. So that's 2.5 million times 6 trillion. Here's a picture, an illustration of our Milky Way. There's a little dot right here that's blue that's illustrated here. That dot is 200 light years across, or 100 light years in radius. That's as far as our radio broadcasts have gotten in 100 years. Space is so large that all these other stars within just our galaxy have not heard our radio broadcast, do not know that we're there on Earth. So we're really reaching out to aliens, but we're not shouting very far into space. This picture is called the Ultra Deep Field. The Hubble Space Telescope, instead of leaving the shutter open for 1/10 of a second or a second, left the shutter open for 11 days, where there was nothing in space, just black. When they processed the picture, they saw this. I believe there are 3 stars in this picture. The rest of it is 2,000 galaxies, each one made of hundreds of billions of stars. That was in a piece of space where there was nothing. So the Milky Way is in space. The Andromeda galaxy's not far away, 2.5 million light years, and this makes up our local group. We're part of a supercluster. Superclusters can have as many as 500 trillion stars worth of material in them. They are huge, and yet superclusters are found throughout the visible universe. Matter is not spread evenly. It's clumped in these superclusters of galaxies throughout the universe. And this is just the known universe. Perhaps there's a universe B somewhere else that we don't know about. There's so much we don't know about. But if we were to send some mail to Duke Farms from way in this corner of the universe, we would have to address it to Kate with this mailing address: Kate Riley, Duke Farms, Farm Barn Lane, Hillsborough, New Jersey, USA, planet Earth, solar system, Milky Way, in the local group, the Laniakea, which means immense heaven in Hawaiian, supercluster, and who knows what universe we're in. So tonight, if you look to the north, you're going to see the Little Dipper with Polaris right there. Polaris is that star that does not move at all. The rest of the stars go right around the North Star, which is in the handle of the Little Dipper. The Big Dipper's upside down above the Little Dipper today, and you'll see that the Big Dipper is just part of the Big Bear, a larger constellation that is a bear upside down. We also see the ancient queen and king of Ethiopia. Cassiopeia looks like a W at certain times of the year, an M at other times, a 3 or an E at other times. Cepheus looks like a doghouse. In the east, you'll see Arcturus. The handle of the Big Dipper arcs. It arcs to Arcturus and speeds on to Spica. It arcs to Arcturus and speeds on to Spica. So that's how I remember those star names from the arc of the handle of the Milky Way. In the south, the thing I'd like you to look for, and this is not just necessarily tonight, the next week or so, is Leo the Lion. He's marked by a reverse question mark, and Regulus, the king, is this bright star at the bottom of the reverse question mark. And here's his tail here. Denebula is the tail of Leo the Lion. If you look to the west, you'll see the twins Castor and Pollux in Gemini. You'll see the bright planet Venus, the bright star Capella. And if you're up a little earlier and look way down low, you'll see the brightest star visible in the night sky, Sirius. There is also a comet, Comet C 2020 F8 Swan. You'll hear more about it, but it will be visible low in the northeast and north throughout the month of May, going into mid-June. And this is the location for it. You just have to Google Comet Swan and you will get this information as well. We have a space shot coming up at the end of the month where Elon Musk's SpaceX, for the first time, will finally send astronauts to the International Space Station. After years and years and years of the space shuttle being retired and us paying $40 million for a taxi ride to the Russians, we will end up with our own spacecraft testing for the first time. Another mission later this year is Mars 2020 with the Perseverance rover. That will be going up to Mars later in the year. You'll have to look and watch for the summer launch date. It's all packed up. It's already in its shell. This is how it looks. It's got a helicopter on board. It's going to be a fascinating mission to follow. For the last 6 months of the year, Saturn and Jupiter will be in the night sky. So get out there. This is the picture at 9 o'clock on September 1st. But in July and August, it'll be lower to the east, to the southeast. And in later on, still after September, in October, it'll be to the southwest and to the west in November. You'll be able to see it for 5 months in the night sky, Saturn and Jupiter. But if you get to a telescope, you will be able to see them magnified. And if you can wait until December 20th, an amazing thing is going to happen. Jupiter is going to catch up to Saturn, and in one telescope view, you will be able to see Jupiter and Saturn in one eyepiece view without moving the telescope for 2 nights. It won't happen again for 12 years. So, you may be new to telescoping or new to astronomy. Naked eye is fine. Go out there in the dark. Get away from your smartphone and TV and lights of your house and let your eyes adjust to the dark. Go out, naked eye, observe. If you want, take your binoculars along. And if you have big binoculars, you may want to put them up on a tripod. Another way is to put up a spotting scope on a tripod. That's almost as versatile as a telescope, and you may have these things around the house. But if you want to get into telescoping, here's a beautiful entry-level telescope. In the 6-inch version, it's $270. In the 8-inch version, like Duke Farms has, if you've ever been to a Duke Farms Ranger Bob program, it's about $400. Tax included, delivery included, right to your door. The 6-inch version weighs about 40 pounds. You never have to get a better telescope than this. Don't get a bigger telescope if you're not willing to carry it outside. The bigger they are, the slower it is you'll set it up. So get one that you will set up. Takes about 20, 30 minutes to put it together. The base has to be assembled. It's shipped in a box. the tube is assembled in a box. And you'll put it together and be able to see pictures of the moon just like this. Pictures of planets like Mars, the storm clouds that go around Jupiter's equator, the space between the rings of Saturn and the planet itself. No, it won't give you Hubble views, but you will enjoy space. You will be able to see the cloudiness of the Great Orion Nebula this winter. That is not a cloud in our atmosphere. That's a cloud of atmospheric dust and gas where new stars are being made in a stellar nursery. You'd be able to see that with a $270 telescope. We did everything we said we'd do. We did it in an hour. We got the extra stuff in. I am here to answer your questions, so hit me with them.
So Ranger Bob, there was a question early on about how many stars are there? Is there any way that you can answer that question?
No, there is not. I mean, the number I have seen has so many zeros after it. It's quadrillion, quintillion, it's a number I'm not familiar with. The Andromeda galaxy, they think, is larger than our Milky Way galaxy. And the latest estimate from just that one galaxy is 1 trillion stars. And that's one of hundreds of billions of galaxies. So it's inestimable, but they think there are more stars than there are grains of sand on the Earth.
Well, that's an interesting way to explain it. There was also a lot of questions about your resources, and so I just want to go over that again with everyone. If you are registered for this program, we're going to be sending you all sorts of goodies in email. Ranger Bob has a whole list of resources and the things that he spoke about in his presentation, and they'll be all coming your way. The other thing is that there are so many classes that are coming up, hopefully at Duke Farms when we're back, but also take a look at our digital portal on the Duke Farms website. There are many virtual classes and there are lots of materials for people to continue their learning about nature. So, you know, we're not stopping here. I think that Ranger Bob, as I said in the beginning, is one of our favorite instructors. I'm sure you understand why. Ranger Bob, you are a super cluster of information. You fascinating facts. So we're going to be signing off now, and I want to thank everyone for tuning in here to Duke Farms and our wonderful speaker, Ranger Bob. Look for those resources, and also please look for future programs by Ranger Bob. You know you're going to have a blast. So thanks so much. Signing off.
Thank you.